So here we have augmented matrices, and they want us to read this and tell them how we know what the solution would be. So one thing you can think about is on the left side of this dash, you could reinsert your x, y's, and z's. So x is this first column, y is this, z is that. So this would be 1x plus 0y plus 0z. Well, 0y is 0, 0z is 0. So this all goes away. We get 1x equals 2. So this little row is the same thing as saying x equals 2. So this one, you have 0x, you have 1y, 0z. So this is the same as saying y equals 1. But here you have 0x plus 0y plus 0z equals 3. Well, that's 0 plus 0 plus 0 is 0 equals 3, which is not a true statement. 0 is not equal to 3, so therefore there's no solution for this question. And one thing you can put down in your notes is if you have all zeros and then a number that's not 0, then this is no solution. Okay. Now, if this had been a 1 right here, then your solution, so you have only 1s on the diagonal, everything else is 0. Your solution would have been simply 2, 1, 3. So that's an ordered triple. But because you had all zeros and then the 3, then that's no solution. So this problem is a little bit different. So it's not like this one because I don't have a non-zero number here. In other words, I could say 0 equals 0, and that is true. But I also don't have this as a 1, so I can't just give them those numbers as my answer. So this is the third possibility. And that is when you have all zeros at the bottom, it means that you have an infinite number of solutions. And when you do that, the trick is to figure out how to put it in the format that they want. So if I were to rewrite this, reinserting my variables, I would have 1x plus 0y minus 2z equals negative 1. And then for this row, I would have 0x, then I'd have 1y plus 1z equals negative 2. So what you want to do is you want to pick the solution that has the letter where both of your equations contain that letter. So notice I have an x here but not here, so I don't want to use the x one. I have a y here but not here, so I don't want to use the y. But I have a z in both places, so I can use my z. And what I'm going to do is I'm going to solve each of these equations for z. So here I would subtract x from both sides. I would get minus 2z equals negative 1 minus x. And then I would divide both sides by negative 2. And I would get z equals, and if you want, you can think of this as a negative on the outside of 1 plus x. If I distributed that, I would get back to where I was, over negative 2. And then you could see very clearly that those negatives will cancel. So 1 plus x over 2. Oh, shoot, I'm sorry. I did that wrong. Let's back up. I apologize. So what you want to do is, we're choosing the z. We're going to solve this for the non-z. So I'm going to get x equals, and I'm going to add 2z to both sides. So if I add 2z, I get 2z minus 1. So that's what goes in the x position, 2z minus 1. And then here I would solve it for the y. So I subtract z, and I get y equals negative 2 minus z. So that goes into the y position. And there it is.